Hi, welcome back to Calculus. Today we're going to be looking at hyperbolic functions, which are hyperbolic sine, hyperbolic cosine, hyperbolic tangent, cosecant, secant, and cotangent. Now, hyperbolic trig functions are one use for them, and it's kind of cool, is if you have like a rope or a cable of some sort hanging between 2 points. Easiest example to think of is maybe a telephone wire or electrical wires running between electrical poles. The shape made by the wire as it hangs from those two places is one of the hyperbolic functions. So I have all these definitions. You can find these in the book we're using as well. Hyperbolic sine is e to the x minus e to the negative x over 2. Hyperbolic cosine is e to the x plus e to the negative x over 2. And then importantly, the other four follow the same basic trig identities that we would normally have for tangent, secant, secant, and cotangent. So hyperbolic tangent is hyperbolic sine over hyperbolic cosine. And it works out to be e to the x minus e to the negative x over e to the x plus e to the negative x. And then the other three are all reciprocals of those three. So that's really nice. It gives us some ways to work with them a little bit. So let me clear the board and let's get some derivatives up on the board. All right, so I have on the board here the derivatives of all 6 of the basic hyperbolic trig functions. You can find derivatives for their inverses in your book. You can also find the antiderivatives for some of them in your book. So feel free to pick around in there, but let's just kind of look at these a little bit. And notice that they have some similarities to the regular trig functions, but they also have some really important differences. So the derivative of sine h u, so I'm using u here, which is a differentiable function, is cosine h u times the derivative of u. Now, importantly, that looks familiar, right? Derivative of sine is cosine. We're used to seeing that. But if we look at the derivative for cosine h of u, it's positive sine h of u times du. And that's a little bit tricky because we're used to the derivative of cosine being negative sine. And then so we have the rest. The derivative of hyperbolic tangent is secant h squared of u times du. For cosecant u, hu, sorry, is negative cosecant of secant hu times cotangent hu times du. For hyperbolic secant, it's the negative hyperbolic secant of u times the hyperbolic tangent of u du. And hyperbolic cotangent of u is negative cosecant h squared u du. Again, you can find some antiderivatives and the derivatives and antiderivatives for the inverses in your book. So now let's do a couple of examples and we'll see how we can maybe work with these a little bit. All right, so let's take a look at 2 examples. First, I want to take the derivative of the hyperbolic hyperbolic cotangent of the square root of 1 plus t squared. So this is relatively straightforward, but it does have a double chain rule in it. So be really, really careful with the derivative. So for starters, I took the derivative of the hyperbolic cotangent. Derivative of hyperbolic cotangent is negative hyperbolic cosecant squared, and then we have the 1 plus t squared still inside of it. There's my u. But then I have to take the derivative of that square root to do my chain rule. So if you do that, the derivative of the square root is 1 over 2 times that square root. If you don't believe me, feel free to work it through, but change that to a half power, it'll work out. But then we still have to take the derivative on the inside. And for the inside piece, the derivative of 1 plus t squared is 2t. Clean it up a little bit, the 2's cancel each other out, the t can tuck on top, and you get the negative hyperbolic cosecant squared of the square root of 1 plus t squared times t over the square root of 1 plus t squared. My second example is really pretty nice. I have the integral from 0 to the natural log of 2 of 4 e to the x times the hyperbolic sine of x dx. Now, first glance, it's a little tricky. It seems like, hey, maybe I should do a substitution, but there isn't really anywhere to put a u in here that's going to make things better. Instead, and this is just a real slick little trick that we can use, since we have an e to the x, let's change this hyperbolic sine into its definition, which is e to the x minus e to the negative x over 2. When we do that, the 2 and the 4 reduce to a 2, so I brought that 2 out front, and that left me with e to the x times the e to the x minus e to the negative x. When I multiplied those parentheses out, I got e to the 2x and then a minus 1. Remember, x and negative x make 0. Anything with 0 power is 1. So when we integrate that, trust me, you end up with e to the 2x minus 2x, and we're evaluating from 0 to the natural log of 2. And with a little bit of cleverness, you can get this to work out to be 3 minus the natural log of 4. So there you go. That is section 7.3. Enjoy your hyperbolic trig functions.